Let us look at integrals of rational functions of sine and cos. So whenever we have an integral where sine x or cos x are in the denominator, carry out the following substitution. T is equal to tan of x by 2. So that tan inverse of t is equal to x by 2. And x is equal to 2 times tan inverse of t. Now, let's differentiate this. Dx is equal to 2 divided by 1 plus t square dt. We already know this. So sin x would be what? We know the identity using tan. So 2 tan x by 2 divided by 1 plus tan square x by 2. So in terms of t, it becomes 2t by 1 plus t square. And again, we know cos x is equal to 1 minus tan square x by 2 by 1 plus tan square x by 2. And in terms of t, it becomes 1 minus t square by 1 plus t square. This is the substitution that we would carry out. So let's look at an example. Integral of dx by 5 plus 4 cos x. Then cos x is there. So we use this substitution. So now we combine these two terms. We get 5 plus 4 cos x is equal to 5 times 1 plus t square plus 4 times 1 minus t square, the whole thing divided by 1 plus t square. Simplifying that, we get 9 plus t square by 1 plus t square. Integral of dx by 5 plus 4 cos x is equal to integral of 2 by 1 plus t square times 1 plus t square by 9 plus t square dt. So how did this come? So here dx is equal to what? Dx is equal to 2 by 1 plus t square. And 5 plus 4 cos x is equal to 9 plus t square by 1 plus t square. But since it is in the denominator, we take it up and convert it into a multiplication with the reciprocal of this. Integral 2 by 9t square dt. Why? Because 1 plus t square, 1 plus t square get cancelled out, which is equal to 2 times integral dt by 3 square plus t square, which is equal to, we take 9 out, so that here we end up with 1 and here we end up with, t square by 9. So that we can write it as 2 by 9 integral dt by 1 plus t by 3 whole square. Now we do substitution. So let u be equal to t by 3, so that du is equal to 1 by 3 dt, which implies dt is equal to 3 du. So substituting it, we get 2 by 9 dt is 3 du divided by 1 plus u square, which is equal to, that 3 we take it out, 3 3s 9, so we have 2 by 3 integral du by 1 plus u square. And this we know that the integral of du by 1 plus u square is 2 by 3 tan inverse of u plus c, and which is equal to 2 by 3 tan inverse of t by 3, because u is 2, t by 3 plus c. T again we have to substitute back. So 2 by 3 tan inverse of tan x by 2 divided by 3 plus c. Or we can separate out this to get 2 by 3 tan inverse of 1 by 3 tan x by 2 plus c. So that was one example. Now let's look at another one. The second one is integral from pi by 6 to pi by 3 of 3 by 2 sine 2x plus 1 dx. So this is a definite integral. So here again we do t is equal to tan x. We are still applying the same substitution. So we have 2x inside this sine, but When we do the substitution, the 2 and 2 will cancel out and we'll be left with x. Okay, so x is equal to tan inverse of t, dx is equal to dt by 1 plus t square. Because here now it is a sine function, we do this substitution. Now, since it is a definite integral, we have to change the limits. So x equal to pi by 6 implies t is equal to tan pi by 6, which is equal to 1 by root 3. X is equal to pi by 3 implies t is equal to tan pi by 3, which is equal to root 3. So sine 2x is equal to 2 tan x by 1 plus tan square x, which is equal to 2t by 1 plus t square. Okay, so now doing the substitutions, integral from pi by 6 to pi by 3 of 3 by 2 sine 2x plus 1 dx is equal to integral from 1 by root 3 to root 3 of 3 dt divided by 1 plus t square times 2 times 2t by 1 plus t square plus 1. And let's see exactly how the substitution is working. So here we have 3 dx. So 3 dx we don't have, we have only dx. So 3 as it is, and dx gets replaced with dt by 1 plus t square. Now, what else is there? 2 sine 2x plus 1 is in the denominator. So 2 sine 2x, but we have sine 2x. So 2 as it is times sine 2x is equal to 2t by 1 plus t square plus 1. So simplifying the denominator, we get integral from 1 by root 3 to root 3 of 3 dt by t square plus 4t plus 1. Now here, let's figure out the discriminant. B square minus 4ac equal to 12, which is greater than 0. So which means we can use the standard formula. So 3 goes out of the integral. So we have dt by t square plus 4t plus 1. And here a is 1, b is 4, and c is 1. So our general formula says 1 by root d, natural log of 2ax plus b minus square root of d, divided by 2ax plus b plus square root of d. So if we do the necessary application of that formula, we get 3 times 1 by 2 root 3 natural log of 2t plus 4 minus 2 root 3 by 2t plus 4 plus 2 root 3 from 1 by root 3 to root 3. And here 2 is a common factor in all the terms, both numerator and denominator. So we take it out and they get cancelled out. So that we are left with 3 by 2 root 3 natural log of t plus 2 minus root 3 by t plus 2 plus root 3 from 1 by root 3 to root 3. Now taking care of the limits, we get 3 by 2 root 3 natural log of root 3 plus 2 minus root 3 divided by root 3 plus 2 plus root 3 minus natural log of 1 by root 3 plus 2 minus root 3 divided by 1 by root 3 plus 2 plus root 3. And 3 by 2 root 3 is common to both. So I have taken it out. Now simplifying this, we get 3 by 2 root 3 times natural log of 2 by 2 root 3 plus 2 minus natural log of 1 plus 2 root 3 minus 3 by 1 plus 2 root 3 plus 3. 3 by 2 root 3 natural log of 1 by root 3 plus 1, because 2 is common to all the terms, minus natural log of 2 root 3 minus 2 by 2 root 3 plus 4. Subtraction, if we combine the natural logs, becomes division. And we convert it into multiplication with the reciprocal. So we get 1 by root 3 plus 1 times root 3 plus 2 by root 3 minus 1. And here root 3 plus 1, root 3 minus 1. The product will be Root 3 square minus 1 square. Root 3 square is 3. Minus 1 is 2. So root 3 plus 2 by 2. So the final result of this integral is 3 by 2 root 3 natural log of absolute value of root 3 plus 2 by 2. So that was the second example. Now let's look at the third one, which is much more interesting, and substitution is a little bit different. Let's see. So we have integral 2 sine x minus 3 cos x dx by cos x plus 4 sine x. It would be nice if it was in the form of integral d prime by d dx. D is the denominator and d prime is the derivative of the denominator. So if it is in this form, it becomes easy. Why? Because then integral of d prime by d dx is equal to natural log of absolute value of d plus c. Just verify this. Natural log of d, differentiate it, we get 1 by d times d prime, which is what we have. Given d and d prime equal to d by dx. Understand this? When I'm saying it, it looks funny, but this is the denominator and d prime is the derivative of the denominator. We want the numerator n as a linear combination of d and d prime, because what we have is n. 2 sine x minus 3 cos x is n, the actual numerator. So we want to convert this into a linear combination of d and d prime. That we do by using n is equal to m times d prime plus n times d. This is nothing but linear combination of d and d prime. So dividing both sides by d, we get n by d is equal to m times d prime by d plus n. Just work out the algebra of that. So that the integral of n by d dx is equal to the integral of m times d prime by d plus integral of n dx. So m is a constant, it comes out. So m times integral of d prime by d dx plus n times the integral dx. And the integral of this is, we know. So integral of n by d dx is equal to m times natural log of absolute value of d plus nx plus c. Now let's actually apply this to our example and see how it works out. So we have integral 2 sin x minus 3 cos x by cos x plus 4 sin x dx. We want the numerator, which is 2 sin x minus 3 cos x, as a linear combination of d and d prime. So m times d prime. So m times the derivative of the denominator, that is cos x plus 4 sin x, plus n times the denominator. So n times cos x plus 4 sin x. We are equating this to the numerator. So what do we get? Cos x plus 4 sin x, derivative is minus sin x plus 4 cos x. So we have 2 sin x minus 3 cos x is equal to m times minus sin x plus 4 cos x plus n times cos x plus 4 sin x. Let's open up the brackets. We get minus m sin x plus 4m cos x plus n cos x plus 4n sin x. Let's combine the like terms. We get 2 sin x minus 3 cos x is equal to minus m plus 4n sin x plus 4m plus n cos x. And now equating the coefficients. So sin x, if we take, then 2 is equal to minus m plus 4n. And minus 3 is equal to 4m plus n. So what we have is a simultaneous linear equation. Solving the simultaneous linear equations gives us m is equal to minus 14 by 17 and n equal to 5 by 17. We can work out this. It's pretty straightforward. Now, let's apply this formula. We have integral of 2 sin x minus 3 cos x dx by cos x plus 4 sin x is equal to m times integral d prime by d dx, which is m is minus 14 by 17 times the integral of the derivative of the denominator divided by denominator dx plus 5 by 17 times the integral dx. And this would be equal to m times natural log of absolute value of d plus nx plus c. So m is minus 14 by 17 times natural log of d. D is a denominator, that is absolute value of cos x plus 4 sin x plus 5 by 17 x plus c. So if you remember this concept, going from here to here is pretty straightforward. Now, this method, you have to be careful when to use it. This method works only when n is a linear combination of d and d prime. That is, n is in the span of d and d prime. This method works only when n and d involve the same family of functions. So in the numerator, you have sin x cos x. In the denominator also, you have sin x cos x. Only does not work if n contains extra or higher degree terms. So for example, it works for 5e to the power of 2x minus 3e to the power of x divided by 2e to the power of 2x plus e to the power of x. Same family of functions in the numerator and denominator. But not for x square plus 3 by x plus 1, because you have higher degree terms. And here, they are not the same family of functions. Just keep that in mind. So that was integrals of rational functions of sine and cos. If you found this helpful, don't forget to like, share, and subscribe. Always looking forward to any questions or suggestions. Thanks for watching and see you in the next session. Bye.